Hi, I would like to show you a quick tutorial to understand the project properties. In this part 1 of 2 videos, we will have a look at one set of project properties, and the rest will be shown in part 2. By clicking on Display Properties, ThunderBench will take us directly to the tool settings, which is the most important section in the properties. Inspecting the tools setting, we can find everything we need in one place. Here you have all the options to control the building of your embedded project in just one area. The first section, the target processor, debugging, and additional tools are global project-wide options that will affect directly your target and application settings. The second section is the assembler-related options. The third is the compiler-related options. The fourth is the linker-related options. Then the additional tool section like the binary output, listing output, and the size format output are extra helpful utilities that we will talk about them later on. In this part 1, we will discuss the project-wide settings. The first entry in the global options is the selection of the Cortex-M core. This option is usually automatically set when we use any of the wizards to import or create a project. If you like to change the core, you can make your selection from this list of ARM cores. This list is supported and constantly updated by ThunderBench. The second option in the target processor option is the instruction set generator. By default, it is set to thumb since it is the choice for all Cortex-M cores. By unclicking the thumb option, the tools will generate ARM-only instructions. The mix ARM and thumb instructions option is where you're using an ARM core and, like the compiler, to decide when to use ARM or thumb instructions. This mix mode is not advisable for Cortex cores. The endianness option is where you select the little or big endian. The default is little endian, which is the default for all Cortex cores. The floating point ABI option is defaulted to software float library. The mixed mode option allows you to mix and link code using both software and hardware floating point instructions. That, of course, requires that your Cortex or ARM device has a floating point unit, or FPU. You also have the option of using strictly hardware floating point instructions by selecting FPU hardware instructions mode. If your Cortex core has a hardware FPU and you choose to use it, then you need to specify the type of FPU. For most Cortex cores, we recommend FPU type FPv4-SPD16. For other ARM architectures, you can specify other types. More details on types and usage of FPU can be found in our documentation and detailed references. Let's now check the debugging options. The first global debug option is the debug level. You have levels 1 to 3. The default is 3, giving you the best debugging environment. The second option is the debug format. ThunderBench uses Dwarf 2. The third option is to generate a stack usage report where you can find information about stack usage from each function. Other debug flags option is where you can add any other debug flags. You can refer to our documentation and references for more debug options. The additional tools section include optional helpful utilities. These features do not impact the code generation of your application. The create flash image option generates an additional .bin flash image or binary file for production. Create extended listing generates extended listings inside the compiler generated files such as -t to display symbol tables. Project size flash and data gives a summary statistics of project size in terms of flash and data used by your application. This concludes part 1 of 2 of the tool settings. Make sure to watch part 2 as well. I hope you enjoyed this video and thank you for watching.